In this video, we are going to discuss solve problem 6.3. Question says a trapeze artist starts his motion when the trapeze is at rest at an angle of 45 degrees with the vertical. The trapeze rope is at a length of 5 meters. What is his speed at the lowest point in his trajectory? So let us sketch the diagram. Let this be the vertical position. This we will consider as the reference point for the trapeze. Now the reference point is a point where we take the height to be equal to 0. Question says that the artist starts his motion at an angle of 45 degrees with the vertical. So this is the point where he starts his motion. And since he's beginning the motion here, the initial velocity at this point, the velocity at this point will be 0. And this point over here will be raised, let's say, at a height h from the reference point. We will take the length of the trapeze to be L, the length of the rope to be L. So L is the total length of the rope. And we need to calculate what is the speed of the artist at the lowest point. So what is the speed at this point over here? Now, according to law of conservation of energy, total energy at any point on the system must be the same. So total energy, let's say at my reference point, I will call this point 1, must be equal to total energy of this point at 45 degrees from the vertical. I will call this point 2. Now at this position at point 2, total energy is given by sum of kinetic plus potential. But at this point, since the velocity is 0, we will not have any kinetic energy. My entire energy at point 2 is just the potential energy. And at point 1, when I write my total energy as kinetic plus potential, at this point, since we take the height to be 0, since this is the reference point, my potential energy at this point will be 0, and the entire energy will just be kinetic. So at point 1, total energy is just the kinetic energy, and at point 2, the total energy is just the potential energy of the system. So we write, according to the law of conservation of energy, kinetic plus potential energy at point 1 must be equal to kinetic and potential energy at point 2. At point 1, the entire energy is just kinetic, so I'll write K1 equals at point 2, the whole of my energy is only potential, so we write Q2. Kinetic energy I can write as half mv squared, and potential will be mgh. I can cancel off the m's because they are common. We get v squared over 2 equals gh. Multiply by 2, so v squared will be 2gh. And take square root on both sides to get the final velocity, which will be root 2gh. Now, this is how we calculate the final velocity at this point, the velocity at point 1, at the lowest point. G is a constant, but to calculate this velocity, I need to know what is the value for h. Now, h is the height at which this trapeze is raised at when it is at 45 degrees with the vertical. How do I calculate this h? Now, total length of the rope is L. The distance from reference point to this point is h. Let the rest of the distance be d. So this is how my rope looks like. This is my rope. The total length is L. This distance is h, and this is d over here. So I can write my total length as h plus d. And we can rearrange this term to write h as L minus d. So if I know what is the value of d, I can find out the value for h. Now, if I take this triangle, we will use trigonometry to calculate what is my d. If I take this triangle over here, we have d at this point, L over here, and the angle here is 45. D is the side which is adjacent to my angle. And you can calculate the adjacent side using cosine theta. So we know that cosine theta is equal to adjacent side over the hypotenuse. Here my adjacent side is d, hypotenuse is L. So we write cosine theta equals d over L, or d equal L cosine theta. We will substitute this in the expression for h. So here we get h equals L minus, in place of d, I will write L cosine theta. And you can write h as L. We can take L common, 1 minus cosine theta. After you get the value of h, let's substitute that in our main equation for v. So I will write v equals square root 2g L. Sorry, let me just rewrite that. 2g L 1 minus cosine theta. So v equals square root 2 times 9.81. Length of the rope is 5 meters, which is given to us over here. 1 minus cosine 45. And when you solve this, you will get your v to be equal to 5.36 meters per second. Now, whenever you have a problem with a rope, a pendulum, a string, or a swing, and you are finding velocity at different position using that rope or the string, we will generally have to find the height h. And that height h will always be given by this expression, no matter what the angle theta. Sometimes in the question, they can give you multiple positions with different angles. And in order to solve a question like this, there will always be a need to calculate h. And h, when you use trigonometry, this is the expression you will get for the height h. So if you can remember this expression, solving the problems will become a lot much easier. So whenever there is a question with a rope, a string, a swing, a pendulum, and they have given you an angle for different positions of the pendulum, this is how you will calculate the height h at which the pendulum or the object is raised at.